Hello, folks. Thanks for coming here today. My name is Mohammed Nufal, and I work as a solution architect in a team called the Azure Global Black Belt team. We are a team focused on technology verticals, and my technology vertical in Azure is cloud native compute and apps, which primarily translates to Kubernetes on Azure. So in my line of work, I work with organizations to help them better architect, deploy, and operate their Kubernetes clusters on Azure. I started working with the folks in DNV GL very early on when they had machine learning MVP on AKS. We've seen this turn into a production system and to a great story within DNV GL, which is a massive organization, and to a stage where now they're considering moving one of their biggest systems to Azure Kubernetes service. Today, I have the great pleasure to have Christian and Esben here with me to share their journey with you. So enough with me now, and I'm going to hand over to them.
Thank you, Mohammed. Yes, we will share with you some of our stories about how we have adopted Kubernetes. Like Mohammed said, we were very early on using it, really waiting for it to go GA. So we have some pains and gains and experiences and advices we'd like to share. That's sort of the main focus of our story. How could we share some of our story to help you avoid some of the mistakes and also motivate perhaps your own organization. I'm Christian Ramsrud. I'm leading a team of a data science team in DNV GL Maritime. And Espen?
Hi, I'm Espen Skaufjord. I work as a developer and architect within DNV GL Maritime.
And some words about DNV GL. We are, like Mohammed said, we are a global company. We are in more than 100 countries and 12,500 employees. And we're doing, in the maritime part of DNV GL, we're dealing with ships. From the technical drawings, which have to be approved for safety reasons, but we're also following the vessels while they're sailing, checking for the safe engines, cracks, issuing the certificate, making sure that the shipping industry is safe, and safeguarding life, property, and environment. That's DNV GL is a foundation, and this is the purpose. This is our purpose. And we're doing this in many industries, not only maritime, but we're also in oil and gas, energy and business assurance, ISO certifications, risk assessments of any kind, and we're also developing software. Doing a lot of research as well. We have two stories or two experiences with Kubernetes. One is the machine learning platform, which is where we have come the longest. And we have the global ERP system. I'm symbolizing this with two pictures here. So, the global ERP system, of course, you have to plan things carefully. This is the moneymaker for DNV GL. You don't want to mess it up. But for machine learning, it was, let's say, low risk. If a machine learning application is down for some time, that means a prediction and advice is not working. It is manageable, right? So it was a low risk, and we could move very fast, adopting new technology and experimenting. And if you trip in one of these hurdles, it falls, it doesn't really matter. We pick it up again and move on. That has been our story. That is why we have come quite far in Kubernetes. And now we have started also on the rocket, on the ERP system. So some experiences on that as well. So about the machine learning platform, the data scientists, they suddenly, we have adopted and have quite a few machine learning applications integrated into our systems. And as they were rolling out more and more, the operations part of it would become a mess, and then to deploy them were really a hassle. So we saw that was the motivation of creating the ML platform. Of course, time to market, it's a pain if you have to do a lot of steps before you're even able to release it. So this platform was sort of the answer to these things. But we're here to talk about Kubernetes, and Espen, we like to share some of the Kubernetes experiences in making this platform, right?
Yes. So, like Christian said, when we had the first ML applications being deployed into our production systems, the situation looked something like this. And we just wanted to add one more functionality. But the problem with machine learning APIs or predictions is that they are not usually developed in .NET or Java. They come in Python, and they are not really trivial to integrate with existing systems. Also, at the time when we deployed our first machine learning systems, tools like app services were not capable of running Linux workloads. So we ended up with having to install virtual machines specifically for the machine learning platform. And being rather early, there was not really ML ops was not really a thing. So this was something the data scientists and the little team around the data scientists had to do themselves with requirements pushed down from the IT organization, such as what operating system to use and how to configure it so that we had security. And there comes the next part. We had to integrate with Azure Active Directory in order to have authentication and authorization. We had to have SSL certificates, and within DNV GL, all general purpose APIs has to be published within the API gateway, so they are discoverable for all employees. All this starts to add up and be a lot of work. And then when you are actually working with the production system, you are also expected to be highly available. So then you have to add the VM scale set, or in our case, I think we did just multiple VMs, and we had to manage them. And then finally, the APIs sometimes needed to have access to internal systems like databases. So then you had to contact someone else to get the firewalls or the virtual private network set up. So this was the job that we had to do to get the first ML application out and running.
And then we have to repeat it every time, right?
Yes.
Every time we had a new machine learning application to be rolled out, we had to go through this, and the lead time to have it up and running was like 2 weeks or something like that.
Yeah. And this was the motivation, and this was driven by the data scientists. They were not interested in this. So they, along with a small development team and some Kubernetes experts, decided to replace, if we go back one step, you see the VM scale set or the virtual machines there, with a Kubernetes cluster. And this gave us the possibility to continuously adding the ML applications within the cluster instead of setting up new virtual machines. Also, we built some software around it to be able to manage it and automatically add the security requirements and also publish it to the API gateway and do security scanning of the source code. So this was the early version. Now it has also gotten a lot more functionality, but we will just keep it to this because this is the AKS part that is probably most interesting to you.
One thing to note here is that doing this was also very well received by the IT organization, because then suddenly we were complying with their requirements for all applications.
Absolutely, and we had a very nice way to govern the ML applications. So we could go to one place and we can see these are the machine learning application that is running within DNV GL. And we are sure that every one of them are secured and that they are compliant. What we want to do is to sort of show a demonstration. But before I do that, I sort of want to know who is in the audience, just to be able to adjust the demonstration a bit. How many here knows anything about writing source code or programming? So we have a few, okay, about half of them. Scripting then, just basic thing. A bit more. The rest of you, are you business, I would expect, or yeah?
Generally interest, I guess.
General interest.
But this demo is showing some of the benefits we get from migrating stuff to Kubernetes.
Yeah.
So you have a small demo showing just the basic machine learning application and how it is now operating in the platform.
Yes, because one thing that was very important when we developed this solution was that we wouldn't want to enforce specific requirements upon the data scientist. We wanted them to be able to work as they've always worked. So what I've done to sort of illustrate this is that I've found a random, well, semi-random ML application that was developed by someone in the Microsoft team. His name is Cesar, and this is his demo application to show how to use ML.NET and in a Blazor context. So if we look into this application that he has written, it consists basically of two major parts. And one more thing, I'm 100% sure that he had no intention of this being an IKS application. This is just a random application, the way he wanted to produce his ML application. So what he has done is that he has split it into two projects. The client project is what runs in the web browser, so this will not change at all. This will be exactly the same. But he has a server component. I think basically, instead of going in that, I'll first show you what this ML application is, so you have an idea. It's a sentiment score. So what it does, it reads the text that you produce, and then it calculates how happy you are or how negative you are when writing the comments. So it's a thing you usually put on feedback forms and that type of information. So if I write here, is nice, it will show that it is, this is probably a positive sentence. So going into this source code, you will basically see that there are two parts to it. The first part is within the startup. I'm not sure if you can see this. We'll try to make it a bit bigger. Oh, and by the way, I'm not a data scientist, so I will not teach you how to do data science work.
If you had been a data scientist, this would have been Python, right?
Yeah, this would probably be trivial. But what it does is they have trained a model based on text. And this model is loaded into the application so that it can be used. And then they have an endpoint where the text that you write into your input is read here. And it is then sent into the model, and the model produces the result, basically the sentiment. So this is all that is required to have this API running. Except we haven't done the training. But when I then want to move this over to our setup, I have to change the configuration a bit because I want to move this part that I'm showing now over to an external API so that it's no longer a part of the web page. This would be a very common way to set up any machine learning algorithms or to consume any machine learning algorithms. So what I did is I took his code and I rewrote it. This is available on GitHub. It's private now, but I will make it public after the talk. And then I did two minor changes. I changed so the server application now that runs the the web application, instead of loading the source, oh, this was the wrong file. It just pulls the authentication, the password to talk to the API out to the configuration file. And then within the controller, it just takes the text that is sent, just like last time, but it serializes it and sends it to an API. So this is the only change I had to do within the web server, but then I had disconnected all machine stuff from the portal. And as the second stage, I basically copied the code that was in his original solution into my own API solution. In the startup file now, I load the model just that was in the old solution. And in the controller, I received the sentiment text that wants to be handled. I load it into model, and I return the results. So now we have a 3-step application instead. And with that done, you can use, we have a custom tool just to publish the application into ML Factory. So when I do this, hopefully.
But now converting this to a Kubernetes application,
yes,
we are getting some benefits in the background, right? Because the code is the same. It's the machine learning application as it was. I mean, just a publicly available machine learning application for downloading. Doing this on this platform, we're getting the benefits of this compliance stuff, security, and so on.
Exactly. Now this is going to build. We're not going to watch it. It takes about a minute, and it will be ready, and then you can deploy it within AKS. So from a data science point of view, the changes you have to do is very minimal. By publishing this, you are compliant at once with the internal security requirements from the corporation. And also, you can do something nice. You can add new features, and these features will be global.
Because that's the benefit of Kubernetes here, right? Because we are now adding new functionalities which are suddenly available for all the applications.
Yeah. So what we have done, one of the services we have added to ML Factory is the possibility to give direct feedback back to the data scientists. This is called an annotation service, and it is being used so that you can retrain your prediction to improve it, or basically get the end users to retrain your application by providing you feedback on whether or not you are happy or you agree with the prediction as they were given. Yeah. So I think this is showing off the job that the data scientist has to do, and showing that there is basically...
But for those who are not, I mean, in the audience, probably not so many are going to make a machine learning platform, but they are going to use Kubernetes for something else. And this is showing this principle of adding new functionality, hitting a wide range of microservices, right?
Yes. Look.
It's working. All right.
Okay, could you just...
Should we go back to the slides?
Yeah.
Good. So, of course, we have a portal for, I mean, the machine learning, the data scientists, they love the CLI tool, but for management, we, of course, have a portal as well. We're not going to go into that, but you see the connection to the API gateway is visible here. You see the usage, so it's showing that functionality. Yeah. How about to succeed with Kubernetes? We think this has to be a teamwork. Now, this is sort of you could see as an obvious slide, but it's also very important. To succeed, you have to play together as a team, all the way from the IT organization up to the stakeholders. And the best example here is the health endpoint. Any application on Kubernetes has to return a health statement. How should that health statement be formulated? This is a business decision, and also from the application developers, they have to agree what is a healthy application. So this is a teamwork, and then the site reliability engineer who will take care of achieving this level of reliability, he would then cooperate with the IT organization to automate and make the Kubernetes setup and the infrastructure, everything to comply with that target. And this health endpoint is also enabling us to monitor it. So that's a very important step. It is defining health, is hitting all the way from stakeholders down to IT organization. Yeah, and not only for health, it's a lot of discussion as well, of course. Some practical pains, issues. Microsoft is in the top left corner, Espen. Why is that?
Because this was on one of our first support tickets for AKS to Microsoft. This was, I think now, about half a year ago or so. We started to have some of the APIs stopping, well, they stopped returning. When we sent calls to them, we got 500 internal server errors. And we were, at that time, not as confident as we are now with running AKS clusters. So the first thing we did was, of course, ask Microsoft for help. And we figured out, working with Microsoft, that this was related to the internal DNS service, which is within AKS. And the recommendation for fixing it was to upgrade it to the next version. But at that time, we were thinking more classical, and we did...
We tried to fix it, right?
Yeah, we tried to fix it.
Fix the cluster.
If you click.
Yes, so...
Yes, what we did, we added monitoring, and we got a script working with Microsoft that enables us to do like a minor fix that made the cluster continue to run, even though we continued to have a bug within the cluster. So until we then felt comfortable about updating to the next version, we had this minor issue. This way of working with AKS is perhaps not a recommended best practice, and we are of course aware of that now, but we were coming from a classical IT infrastructure where you feel that you take care of your servers and they will take care of you again.
So then we, like we said, we started out with the classical way of doing things, with the development staging, I mean, many physical clusters.
Yes, just as classical thinking in the other part of the solution, we decided to create one cluster per environment because that is the way that it felt safe. You have one for development, and then you have one for staging, and then you have one for production. That way you have isolated each environment physically, and you can have specific user rights to each cluster. But as you gain sort of like an experience running Kubernetes, you see that this is not necessarily the best way of doing it, because you get a bit of maintenance. You have to still, even though it's highly managed by Microsoft, you have to maintain them still. There is a bit of work. And also there's a cost related to it. The staging clusters, even though they were hardly used at all, they cost just about the same as the other clusters. So what we did then is that we decided that as this is a cluster and it has support for what's known as namespaces, you can move your environments into one cluster and share the resources and then get better utilization. And unless there is a very specific reason not to do this, when you have the confidence, this is absolutely something I would recommend as a practice.
I think this shared environments on the same cluster, this was a key learning for us when taking this to, I mean, showing benefits to the ERP system. Because, I mean, working with an ERP system, they're doing intensively testing in a lot of environments. So managing those environments was actually quite much work for them as well. So having this experience from our side on this small project was really valuable.
Yeah, bringing up like a complete environment with virtual machines, databases, used to be a lot of work. But when you start to think about it differently within AKS, this is actually getting more and more trivial.
It doesn't mean that you have to do it this way. It's up to sort of your confidence, right? Your requirements, your confidence. But based on our experience, we saw that this is the right thing for us. But you have the flexibility to do it like this. Right, next support ticket.
Yeah, this is not a support ticket, but when we started our journey, we had some features that we knew we needed from the get-go, but these were not available within AKS at that moment. So we started without actually having them, hoping that they would come as soon as possible. And now they have, well, many of them have been released already, but there is a small little catch there. You have to recreate the cluster often. You cannot just tick a box and then you will get some of this functionality. They require actually to take down what you have and create it again. And when doing this, it's important that you make sure that you keep the resources that you want to continue having, especially your public IP address, so your DNS registrations will continue to work. But when this happened, this sort of hit our mentality a bit as well, didn't it? We were starting to get aware that our clusters were no longer going to last forever, and they were not special at all.
And we got some good advice from Mohammed, right? So we thought, okay, recreate cluster, that has to be no issue. We have to come to that position that we just do it. So that means we had to change our mentality. We shouldn't fall in love with our clusters anymore. Like, you should treat them not like cattle, not like pets, more like cattle. Of course, we love the cattle as well, but I mean, we don't do anything possible to save this one server. We replace it, right? We upgrade it. We do full DR and deployment plan, and now. I mean, this was a big relief for our team when we suddenly had this in place. Going from 0 to a fully restored service was now 7 to 8 minutes.
This is actually a direct copy and paste from an email we got from a guy at DevOps. And being at this position, you are pretty confident about your situation. Because if you knew your cluster worked an hour ago, and then something happened, you did something, and it starts to have issues. If you can restore the state it was an hour ago within 10 minutes, that's the fastest way you can get your solution up, without any doubt. Just writing the support ticket to Microsoft would probably take longer. So this is now a very efficient way to drive your clusters.
Yeah.
And then, there was supposed to be a Microsoft up there as well.
Yeah, okay.
We forgot it. Incident 2. This one is interesting. We had a bit of an eager employee. This is on our dev environment, not our production environment. They decided to go up to the latest version of Kubernetes in Azure, looking at the portal and selecting the latest and greatest and pressing upgrade. If I'm not wrong, I think Mohammed could support me here, but I think this was actually a pre-release, even though it didn't say pre-release. And this caused our development cluster to get lots of strange behaviors that we were not expecting. But at this time, we were already confident about actually fixing this by removing it and replacing it with a new cluster. So it was far from the problematic situation that we thought we would be in.
I think it was some stress behind the scenes in Microsoft as well. but this was a good learning part here. It's just, restore.
Yeah, be confident about bringing your cluster up. And this is where the infrastructure as code comes into play. You code your cluster in the way that AKS clusters is basically a definition of desired state. So as long as you have your definition file, so how you want your cluster to be, you can just create a new cluster and give that cluster the exact same desired state. And the cluster will automatically restore itself to the state you want to be in. So having that possibility is really valuable.
Yes, just repeat that. Kubernetes is like declarative. That's the system is working to restore your specification of the state, right?
Yeah,
so
you never really install software to Kubernetes. You ask it to have a state, and if that state requires it to be a software installed, Kubernetes will install this software to achieve its desired state.
Very well. So I think this is also not only it's not about Kubernetes, it's psychology. It's the Dunning-Kruger effect. Some psychologists have formulated this. When we think we're performing. When we have less knowledge, we can actually feel more confident. We don't know what we don't know, but we believe we know everything, right? We came out with a lot of Kubernetes-specific experience. Really high competence in the company on Kubernetes, but we didn't really know how it would be when deploying this into an enterprise context. So there was more to it than we thought. It was not only about being a Kubernetes expert. It was to have this sort of as a part of a bigger context. So, we believe we are here right now on this. It's starting to make sense. But we still are on the learning curve. So according to this curve, it could be even worse, right?
We're on the way up.
Yeah, but no, but we feel we have come a long way. Then we have the ERP system, Espen. That's a bigger chunk to bite, right?
Yes, the ERP system is, I think, now getting close to 15 or 20 years. It consists of multiple services, multiple databases, multiple versions of frameworks, and moving this. Well, there's been a decision taken that we want to improve the capability of deploying or to improve the ERP system faster and be more agile. And one of the things that has been decided there is that we need to go to the cloud to get faster turnover. So we started then looking at options. And the first options we looked at was lift and shift. This is basically taking the virtual machines you have on your on-premise installation, or at least we have on our on-premise installation, and copying them as they are into the cloud, recreating your on-premise environment. We actually did a test for this and saw that it would work. But we also saw that it wouldn't really give us the benefits we were after. Sure, we wouldn't have to maintain the servers, but we already had the competency and qualified people to do that. That was not what we were looking for. We were looking to have a better way of running it. And in many ways, app services is the same way. It just removes a couple of layers, and that is when you, well, for those that don't know what app services is, it is a web service hosted by Microsoft, really. And we could use that, and we tested it, and it seemed to be better than virtual machines because we would have less responsibility. But in the end, it would put us in exactly the same position we were. We would still deploy our applications to IIS, and we would still communicate through the open network, and we would not really gain any of the architectural benefits from this. But for sure, the operations would be a lot simpler. But then, parallel with this testing, ML Factory was going on.
We were working on, ML Factory, but I mean, AKS was sort of the desired state, but there was a lot of uncertainty about it. It was felt as a huge step into the uncertainty. So that's why the ML Factory story came well into place to gain experience. So we saw that since we had been working on ML Factory, since we had operational experience with it, we thought, or we showed this to the ERP team, the architects, they really liked it, and we saw, like I mentioned, the middle point here about the environments. It was very attractive. Like I told you, there's multiple environments in these ERP systems. And let's see if we could find some low-hanging fruits. Again, something play down the risk a bit and get experience in the ERP story on AKS.
Yes, and by looking at the low-hanging fruits, we could focus on getting the AKS environments up correctly. We could focus on integrating with the already existing DevOps pipelines, because they have already a very complex system there. And then, finally, we could find some applications that were low risk, but still integrated within the ERP system. And we already now have our first application up and running. And we are looking into moving more in the time coming. But still focusing on the low-hanging fruits, we will soon move over to focusing on the applications that requires high agility, fast changes, where we really need the best benefits from AKS. But this is a completely different challenge than what we had when we were working with ML Factory, because within the ML Factory, each application was a separate entity. Here, we have to look at more complex scenarios, and we have to look at changing the entire architecture of parts of the service. But this is the path we are going, because we feel confident that this is what will give our system the best future and the highest return of our investment.
But there are big let's say, differences in these systems. The machine learning applications, they are standalone applications, right? They do one thing, they do the prediction of one particular machine learning problem and the return a prediction, estimate, classification, whatever. But the ERP system, then you have microservices which are cooperating. So that's new challenges, but still it's the right place to go.
Yes, we already have multiple microservices and, well, multiple applications within the ERP system, but we are bringing it all over now to AKS. That's the plan over time, at least. But we are not in a rush. This is not going to happen in like 5 months. We will do this slowly and safely to make sure that we can keep an operational,
And that's up to every project, of course. Some applications could be easier to migrate than others. But for those who are very sort of tightly integrated, you have to identify the microservices which are best available and focus on them and pick those first.
Yep.
Very good. Key takeaways from our story. We have this victory podium here. I think don't be afraid to start. That's the first step. I think that's not.
And find the right personnel. Find the people that really wants to do this. The ones that are motivated. Give them a chance to work with it, and they will gain knowledge really fast. It's not as complicated as one would think.
Start with disaster recovery or
infrastructure as code. This you should have from the get-go. There is no doubt. It will give you a lot of confidence about what you're doing, and it will enable you to recreate environments really fast, and it will give you perhaps extremely many benefits that you cannot get in any other way, I think.
And on the first place, keep it simple. This is actually very, it sounds simple, but it's very true. Kubernetes has a lot of opportunities. It's a lot of tunings. You could install all the features. There are always some open source projects, something you could add on to your Kubernetes setup. Don't do it unless you really need it, right?
No, exactly. Be sure that what you're installing is something you actually need. And there are tons of projects out there. And many of them bring you excellent features. And they can really make your life a lot better. But only if you need them. If you keep on adding functionality that you don't need, you're just going to give yourself an overhead in maintaining this system. So keep it simple, do what you need, and make sure that you get it running up and safe.
And adding on to this, you were talking about the right people. I mean, get some competent people on the team, or somebody who are sort of on the willingness to learn, because you have to be open to what's happening in the open source community. And we discussed this earlier today, that some in our teams, they are always looking for new opportunities, and that's how it should be. And coming in with some enthusiasm and chunking a bit on it and thinking, okay, that was probably not the right project after all. But be out there, look for new opportunities and be positive, but keep it simple, right? Yeah. That's actually it. Don't forget to evaluate this session. And Mohammed, or anyone, questions, comments?
No? Yeah.
Oh, yeah.
Can you go just by the mic?
You had mentioned the incident number 2. Do you know what was the underlying issue for that you guys, and how you guys overcame it? Was it tunnel front?
What?
Was it tunnel front?
Yeah, I think it was tunnel front, yeah.
Okay.
It was tunnel front and the API service, I think, that had some issues.
So how have you guys kind of overcome that going forward?
How
have you overcome that going forward?
we reinstalled the cluster to an older version to get away from the faulty pre-release version that we installed using the portal.
What version was that, you know?
Oh, I think here in South 1.14.5 was the one or something. No. 1.12. No, was it? Yeah, 1.12. Yeah, okay. I don't remember.
It was
really.
back in May, yeah.
So I don't remember what version, but it was right before build.
Yes.
Because I'm pretty sure this bug came because they wanted to push some new functionality for build.
Yeah. Any more questions? Yeah. Yep.
Do you, you mentioned a lot through AKS. How much did you have on-prem? How many clusters and how big? And how did you manage them?
We are not running on-premise clusters at the moment. There are discussions about it, but at the moment we would prefer to have them in Azure because of the benefits basically with maintaining them. But we might end up having to do it in some applications.
And is that the same for the ERP system as well?
The ERP system is running on-premise, but it's not running in Kubernetes.
Right.
So this is running on standard IaaS application service.
So our scenario is very similar to your ERP, is
Yeah.
you're taking this huge monolithic application
Yeah.
and breaking it up over like hundreds of nodes across multiple clusters
Yeah.
across different continents.
Yeah.
So the
All
ERP
private.
system.
This is our story as well, and
Yeah.
you can, like the one thing you notice when you start with this, even after the first meeting, is that you're not going to do this in one go. It's too big a change. You would have to stop all development for half a year just to prepare for the one launch, and that's not going to happen.
So find the pieces which are easy, and the biggest blocker is the database. I mean, the ERP system is querying across the database, and just how to deal with that. That's the biggest challenge.
Yeah. And identifying the services for us was like 50. We thought, oh, it's only 50 services, and we looked how complicated each one was. We wanted to be 200 of them. We wanted to break them up into.
Yeah, I think we currently actually are running something like 80 or 90 microservices, but they are of different types of various, like they are mostly running on, well, many of them are running on older Windows versions. I think now actually AKS has support for Windows nodes as well. This is brand new, but we are not sure if we want to go that way. We'll just take the ones that are .NET Core and focus on getting those over.
All my questions are on-prem now, so.
Yes, sir.
More questions? No? Mohammed? Any comments from you? No? Yeah.
Thank you all for being
Thank
here.
you all.
And,
Yeah.
enjoy the night.